Earthquake! Ah! Okay, we survived. Okay, good. Sorry, I was bored. All right, so 5-9. In lesson 5-9, we'll be looking at powers and products and quotients. And you might be going like, what? Powers meaning exponents. Products meaning multiplication problems, and quotients meaning division problems. So today we're going to be looking at what happens if you raise something to a power more than just one variable. What happens if you raise multiple variables together to the same power? It's actually really easy. It just, once again, it takes two ideas we've kind of already learned, rules we've learned with distributive property, almost like distributive property, and then the rules about what do you do when you have exponents on an exponent? What do you do when you got a variable times another variable and they have exponents? You know, you're supposed to add the exponents together, okay? So this should be kind of a reminder of some stuff we learned in chapter 4. I know that's been a little bit back. It's been like, a week or so back, but you got to remember these things. So let's just go ahead and get started. So here's a problem. Now in chapter 4, we would have seen a problem that might have been like this, but it would have just had x to the third being raised to the second. And that would have just been x to the sixth. But here we have 3x to the third raised to the second power, okay? So the question is, what does this become? Well, this too is saying whatever's inside the parentheses, I have that doubled times itself. So that's like saying I have 3x to the third times 3x to the third. Now we've done problems like this. If you can get from here to this step, this is old school problems that we've done in chapter 4 already done stuff like this. So you get 3 times 3, which is 9. So this is going to equal 9. And then when you multiply the bases, you do what with the exponents? You add those exponents. So 3 plus 3 gives you 6. So you get 9 and x to the 6th power, okay? Now that's one way of looking at it. Another way you could have looked at it is it's almost like you're taking this power right here and you're distributing it. Now you're only allowed to distribute this exponent if the problem is entirely multiplication on the inside, okay? You see how we're not adding or subtracting. It's only saying 3, it's saying 3 times x to the third. That's all multiplication right there. So you can distribute it. If I did, I would get 3 to the second power, and I would get x to the third, and then the x to the third is raised to the second. I only put parentheses here just so that there's a difference between the 3 and the 2. So if I didn't put the parentheses there, that would look like a 32. So we got to make sure we do show that there's a difference there. That's why I did include the parentheses. So what is 3 squared? Well, 3 squared would be 9. And x to the third to the second power. This is when you multiply. Remember, you add when you've got two bases like the x and the other x, you would add these two. But here you're going to multiply because the parentheses in between them. So you still get x to the 6th. So regardless of how you do it, you get the same answer. Some students can just see it one way or the other. Now, once again, this is new material, so go kind of slowly at first because it's real easy to make mistakes on this. All right, next. This is the same thing as saying x to the 5th, y to the 2nd. I'm going to put parentheses around it because I got to put the 5 here. So x to the 5th, nothing's happening to him, but this one, something should be happening. We got a little multiplication going on. So I got x to the 5th and y to the 10th. That is my final answer for that problem. Pretty simple. Honestly, this section is pretty simple. Next, we have -5 and x squared. So once again, you could think of that as -5. Now, if you have a negative number and you are squaring it, you do need to put parentheses around it because you're saying the whole thing is being squared, not just the 5, but the -5. Now you have x squared. So x squared can't do anything, but the negative 5 squared, well, what is negative 5 times negative 5? It's positive 25. There we go. And of course, we could box it in just to make it all stand out so nicely. All right, got 2 examples here. Not bad examples, not bad examples. So remember that when you have something raised to a power, it means that whatever is inside the parentheses appears that number of times. So it's like saying I have 2/3 and 2/3. Because it's an exponent, it says I'm timesing them. I think we've done this before. If you multiply these two, you end up with what? 4/9, okay? And that is your final answer. Now you see you could write it out like this, or you could say you are allowed to, again, you can distribute this if it is a division problem and that's all it has in it. So see, this has division. No adding, no subtracting. So long as it doesn't have those things, we're good to distribute. So it's like saying I have, I'm going to have to write this down a little lower just so it doesn't get cramped with this stuff. Let's write it down a little lower. It's like saying I have, keep writing this wrong, 2 squared. It's like taking that square and putting it with the 2, and then take that square and put it with the 3, and I have 3 squared. I don't know why I keep putting a 4. There you go. Okay, now it's written correctly. It's getting late, guys. It's getting late. So I've got 2 squared, which is equal to 4, divided by 3 squared, which is equal to 9. Once again, just showing you that you got 2 different ways to work it out. You could write it out, or you could do it like this. Writing it out is fine when you've got small exponents, but what happens when you start getting larger and larger exponents? You might not want to write it out a whole lot of times, okay? It gets tiresome. So this way it might be the easier route, especially once you start using larger exponents or you have a lot of variables. It's just easier. Okay, so this next one we're going to just distribute. So remember, the 3 gets distributed to everything. So you could say the 3 gets distributed to the 4, it gets distributed to the x, it gets distributed to the y. So I end up with 4 to the 3rd power, parenthesis, x to the 2nd, parenthesis, x to the 3rd. See, I got to put in parentheses so that I don't, once again, think that that's a 23. Divided by y to the 3rd. Now my y to the 3rd is the only thing here that actually doesn't need any help, but my top numbers can be worked out a little bit more. We're not done simplifying, okay? So to simplify this further, we would end up with, well, what's 4 times 4 times 4? That would be 64, and you'd have x to the 6th power divided by y to the 3rd power. And that's it. We're done. The whole kit and caboodle right there, guys. You have all the information you need to be successful in this section. And since this is the last section, I hope you guys will take time, since this one was so easy, I hope you would take time to go back and look over your notes and worksheets and get ready for that test that'll be coming up soon. You know, it would be the smart thing to do. You don't have to do it right now, but it would be recommended. Alrighty, well, I look forward to seeing you in the classroom. But before I go, I want to give you one quick thing. I'd like to give you a challenge problem. A challenge problem that I will make up here on the spot. This is something that you can take with you into the class and see if you can come into class and have it solved, okay? Let's say we had something like -3 x to the 2nd, y to the 3rd, divided by 5. And then we're going to have, down here, we're going to have a to the 4th and b to the 6th. And we're raising all of this, we're raising all of that to the, well, why don't we just go ahead and say the 3rd? Yeah, the 3rd power, okay? We'll keep it not too complicated. So I'd like you to try this and see if you can do this. Come into class and see if you can impress me. I challenge you to try to do this without your parents' help, okay? See if you can get this done without your parents' help or older sibling or anybody. Just you and your brain and, good instincts. Or, you could use your notes to help you. Just saying. See you in class.